you my background, a little bit of my background, and then and how I got involved in this subject, and then I'll take questions. I'll go through some technical material, so bear with me. I think some of the basic technical facts is important as a patient or an environmentalist or anybody who lives in this world today. And so bear with me on those, but I will take questions at the end. And this started for me about 1975 when when I became involved in an industry that was just being born, which was cleaning up toxic waste dumps in Philadelphia. And that was before the federal law, which is called the Resource Conservation and Recovery Act, which mandates the cleaning up of love canals and past toxic waste dumps. And I was trained very early in this industry on how to go into a site, evaluate groundwater contamination, surface water runoff, soil samples, air samples around a toxic waste dump, and then try to figure out how to clean them up and abate the site or chemically neutralize it or whatever could be done. And in the process of this, we would do all these testing on the site, and I would say to my colleagues, more often than not, well, you know, there's people living 50 yards away from this dump, and we're testing the soil, the air, and the water. What about the people? No one's even done any medical studies or evaluation on these people who have obviously lived next to this dump for 5, 10, 15, 20 years. And it just seems sort of incredulous to me that no one was really looking at these areas and looking at the impact of public health. And it took me probably about 15 years to really ever come to the answer to that question, why wasn't that being looked at? And unfortunately the answer was that most people, particularly government and industry, didn't want to know. They didn't want to look. Even some of the people didn't want to look. And if they found dioxin in their body, in their house, well then what's their house worth? Since they took everything they earned and saved in a lifetime to buy their home, if it now is worth nothing, then it was devastating. And eventually that happened to many of these people. I ended up chairing the Toxins Committee for the Sierra Club in Northeast United States, and this was out of Philadelphia, and became increasingly involved in looking at technologies that would clean up toxic waste dumps. I went back to do graduate chemistry because more and more I was finding that the problems regarding the environment and human health had to do with chemistry, even more so than medicine in certain ways, and became involved in it from a chemical aspect. I was then transferred to California about 10 years ago by this company, and ended up going into environmental health and its relationship to medicine full time about 11 years ago, and I'll talk a little bit more about that later. But that's just some of my background. I'm the president of Health Med, which is a medical management corporation that manages and administrates for physicians who practice in the area of environmental occupational medicine, the diagnosis and treatment of chemical exposure. And so that's sort of my background. I'm the president of that group. We consult with physicians like Dr. Carey or other doctors around the country that wanted to do this. I'm also a founding member of the Foundation for Advancements in Science and Education, which is a medical research and education foundation that does and has performed various scientific studies on human toxicology and the effects of chemicals on health and detoxification. So I'll talk about that later tonight. In addition, I am the director of the Kirstie Alley Foundation, which I and the actress Kirstie Alley founded in Los Angeles, and it's a philanthropic foundation, and we do environmental education for children. So we publish environmental education materials for children on problems that relate to children and solutions that they can do. So those are sort of the major hats I wear, besides I have 4 wonderful children and a wife that I miss. I've been on the road for about a week. Okay, let's go to chemicals. Because I don't know this audience, I know 2 people in the audience, and one is almost my peer when it comes to chemicals and understanding them, for sure. But I don't know where all your interests are, so bear with me. I'm going to go through some basic facts, and I hope it isn't boring for you. If it is, yell. Since 1965 in this country, we have produced about 3,000 new chemical compounds a week. we create in this country about 3,000 new chemical compounds a week. There are over 4 million chemical compounds on the books that man's contrived. 70 to 80,000 compounds are in normal daily life. That would be in domestic or work environments. So we live in a chemical world. That's not all bad. The building we're in, the computers you use, the cars you drive, the video cameras you record with, certain medicines that save lives, all these have to do with, have been contributed to by the chemical industry, and it's our standard of living. It's intimately connected to this. I used to say to fellow Sierra Club members when they would complain about industry, those guys are bad and we environmentalists are good, I'd say, well, you drive a car? And they would say, to my fellow members, well, yeah, I do drive a car. Well, do you know that the average American car generates 2,600 gallons of toxic waste? Oh, no, I didn't know that. So, well, you get the car, someone else gets the waste. But it is your problem. It's all of our problem. Not that industry has always looked in advance as much as they should have regarding certain chemicals, or when they did find a problem, take responsibility correctly, but nevertheless, it does contribute to our standard of living. But it also, there's a price that we're paying with our health. And I think that the literature today, the studies that are being done today, are increasingly showing that. We live in a chemical world. There's just no doubt about it. One of the basic principles of this, which I wanted to, if you bear with me, because I think it's important to understand, and I don't know how everybody's going to see this, is organic chemistry. Just very basic, just a very basic, simplistic aspect of this. You have organic, inorganic chemistry. And organic in chemical terms does not mean organic like organic vegetables and gardens, okay? Organic simply means it has carbon in it. So a molecule or a molecule that has carbon in it will be organic. For instance, wood is organic. It has carbon in it. Metal is inorganic. It has no carbon. So normally your metals, your minerals are inorganic, and about everything else is organic, because most things, living things, all have carbon in them. Okay, so it is the carbon, the organic area. To give you an idea, I mentioned over 4 million chemical compounds. There's about 70,000 known inorganic compounds or elements, and the rest are all organic. To give you an idea of the disparity between inorganic and organic compounds. And that's important for you as just a common citizen to understand, because those organic compounds are made from the number one source of hydrocarbons on the planet, which is crude oil. That's where they come from. That's where the majority of these chemicals come from, is the synthesis, the distillation, the refinement, the combination, etc. of crude oil. We consume, our life is built around the extraction and conversion of crude oil. And it might be the death of the planet eventually, since all known crude oil reserves on the planet are right now expected to run out by the year 2040. So it's not that long. We have to really get to working up some alternative energy sources, not just because crude oil is so dirty and has such health consequences, as we don't have much of it left. And I don't think that the oil companies are going to develop the alternative energy. Hopefully somebody else will. Nevertheless, you take a carbon molecule, and I'll just give you an example of this. And the reason you can produce so many carbon molecules is because the way it combines. If you have, like, for instance, a string of carbon atoms connected with hydrogen, these are little hydrogen bonds that connected, you can build this like Tinker Toys. And every time you add a carbon, you can take it this way and add a carbon, this way and add a carbon, add a chlorine over here. And every time you can make this chain go all the way over here off the wall. And every time you add or change or subtract to that configuration, you're going to change the chemical and often the physical properties of the chemical you have, from a liquid to a solid to whatever. And so the combinations are infinite almost, what you can do. So this is what's called a straight chain carbon. To give you an example, ethanol, which is alcohol in a beverage, is a straight chain carbon, which means it goes in a straight chain. Carbons in straight physical chains. Okay, now, yes. Oh, okay. I just drawing examples, okay? Okay, now, The next carbon type molecule is very important, and then I'll be through molecular chemistry for the evening, but I want you to see this because there's a reason. The next form is a carbon molecule that is formed like this. In chemistry, that molecule, these are all, okay. These carbons are in a circular fashion. In chemistry, that's called aromatic. Has nothing to do necessarily with how it smells, which could be misleading. Aromatic in chemistry means circular. Okay? Now, the important thing, that happens to be the benzene ring. That's benzene, which is a very carcinogenic, immune-suppressing chemical that you find in the exhaust of cars, in many cleaning, paint type of products, and so forth. The thing that you should note about this molecule is, because of its actual circular round construction, it's resistant more to breakdown. It tends to be harder to break it down, and it tends to persist in the environment longer than a straight chain like alcohol. And that poses some interesting qualities and some interesting health problems, and I'll get into that. The circular. Now, the way you can take this molecule, okay, and what you can do with it in organic chemistry is you can add another benzene ring here, just right off the facets here, and every time you add that, put a chlorine here, bromine here, and every time you're adding and exchanging these atoms, again, you're getting a new chemical. So again, the prospects are infinite. It is the aromatic ring that, when attached to a chlorine, a bromine, an iodine, the inert gases, if you remember your high school chemistry, iodine, bromine, chlorine, fluorine, one of those gases attached to the aromatic ring is usually where you get some of the worst potential cancer-causing chemicals known to man. And I'll get into some of those, but that's where they come from, some of the worst things you've heard about in the news, and I'll discuss that a little bit more. The subject of, low-level toxic chemicals. In other words, we're not talking acute poisoning or acute exposures. We're talking normal day-to-day exposures to the chemical makeup in the world I just described we live in. What does that do to your health? For years, Herman Dow, who was the head of Dow Chemical, used to call anybody who was concerned about lower levels of chemical exposure, like you or I might have in a day, chemophobic. Microchemophobic, meaning scared or paranoid of low amounts of chemicals. Okay, he actually coined the word. In fact, though, the traditional mainline medical scientific literature is showing in an increased fashion today that there is health effect from lower levels of chemicals. And I'd like to cite a couple of those studies for you and explain them in layman's terms. Okay, one study was done in Los Angeles by the University of Southern California. John Peters, who chairs occupational medicine there, used to chair it at Harvard, he conducted a study in LA households. This study basically looked at 1,500 homes in LA. In certain homes, people sprayed pesticides in the home, black flag, raid, to kill bugs. He compared those homes to homes that did not spray any pesticides. What he found was that the incidence of childhood leukemia in the homes that were just spraying household pesticides once or twice a week was 7 times higher than in the homes that did not. Very measurable difference. Okay, in the same study he looked at, there were certain households where one of the parents worked with solvents, industrial cleaning, dry cleaning compounds, paint thinners, solvent-type chemicals, degreasers. In the households where one of the parents worked with solvents, the incidence of childhood leukemia was approximately 5 times higher than the homes where neither parent worked with solvents. The exposure the child was getting was from the clothing of the parent when he came home from work and his breath or her breath, because you would exhale the chemicals. Okay? Now we're not talking acute emergency room exposure. We're talking common, everyday, apparently innocuous exposure causing measurable death increases from cancer. That's a published major study. The California Department of Health just published a study last year which showed the amount of lead in an urban environment in California, any of the urban environments of California, was effectively reducing the IQ of children 4 to 6 points alone. The lead was coming from old lead paint, dust from old buildings and schools, the smog, the lead in exhaust from cars, and lead in soldered joints in plumbing in homes. That's where the three sources of lead were. Now, remember, when we say unleaded gasoline, many people think that, oh, this is great, it's great for the environment. Unleaded is sort of a euphemism. It just means less lead. It has to have lead for the octane in it. It just lowered the amount of lead allowed in it. It's not unleaded. Okay, so when you drive a car, you're going to spew out a certain amount of lead out the tailpipe, even though the catalytic converters and the unleaded gasoline greatly reduce it. So children are being exposed to lead from old paint, and from plumbing, particularly where the pipes have soldered joints, because those soldered joints usually have lead in them. That leaches into the water. The kid drinks it. Lead is toxic to the central nervous system at lower levels. So we're not talking acute lead poisoning here. We're talking lower levels of lead exposure that are now you're able to measure measurable harm. Now, how does that translate? Well, the kid loses 6 points of IQ. He doesn't notice it. His parents don't notice it. Maybe he doesn't get into the high school he wanted to get into. Maybe he doesn't get into the college he wants to get into. Maybe he doesn't get the job he wants to get. He's just a little duller for whatever reason. It goes unnoticed. It's subtle. It's not acute. It's not like he's in a seizure from an acute toxic exposure going to the emergency room. And that, I think, is one of the biggest risks that we talk about today. The effects are subtle and gradual. They build up over time. And for that reason, you're lulled to sleep. You don't really notice it at first. And yet the quality of life is being dramatically affected. Dramatically affected, even though you don't see acute apparent illness all at once. That study was published. The U.S. EPA published another study, which came out just a couple of years ago. And that is a study where they take human tissue samples from around the United States. They actually take a little fat biopsy, the gut or the buttocks, and they take these samples from urban and suburban and rural areas, northeast, south, southeast, etc., all different geographical areas. They pull them and they analyze this human tissue for chemical levels in it. In other words, what's the general population accumulating in their body? What chemicals? Are they increasing? Are their concentrations increasing, decreasing? What's going on? It's the only kind of study of it in the world, and it's been ongoing by the U.S. For about 30 years. In that study, the last published report, they found some 60 toxic chemicals that are known or suspected carcinogens, known or suspected immunosuppressing chemicals, or neurotoxic chemicals, 60 chemicals in literally the entire population of this country. So that means everybody sitting here, myself, levels of things like, and I'll go into these and what they are, like DDT, the pesticide, like PCBs, which was in electrical devices, like PBBs that was spilled into cattle feed over in Michigan back in the early 70s and came across to the 12 adjoining states. Toluene, which comes from various cleaning products and household chemicals and paints, thinners, and things like that. Benzene, which I mentioned. Lead, dioxins, which I mentioned. These were found in literally the entire population. Now, you might say, well, all right, so we all have a little bit of stuff in us. What does that mean to me? What downside does that have to me? And I think one of the most significant papers on that question just was released last week, and that was from the University of Michigan. It will come out, I think, next week in the Journal of Environmental Archives. And it showed that in a study of women, I sent it to Dr. Carey before I left Los Angeles just so he could have a copy. It might have come in, but this was a study of a large cohort of women who had tumors in their breast. Okay? And in this study, they took those women that were screened that had tumors in their breast, and they took fat samples from them, tissue samples from them, the gut, here. And they analyzed that tissue for chemicals. What they found were the women who had malignant tumors had 60% higher chemicals, pesticides, in their fat than the women who had benign tumors. 60%. clearly a significant statistical relationship between the onset of breast cancer and the actual physical level of chemicals that are stored and built up in the body. So these things do have effects. Now you might say, well, cancer, not a lot of people get that, and so forth. Deborah Davis, who's one of the chief toxicologists for the National Institute of Health, published a study last year in Lancet. She's a colleague of mine. Deborah showed that in the 6 industrialized Western countries, cancer, most forms of cancer, with the exception of lung and a few others that are directly related to smoking cigarettes, is out of control. In the industrialized section, definitely in the paper, she relates it to the increased use of chemicals, and that's cancer. We in this society, we judge everything, every chemical or food additive or what have you, by its contribution to the creation or onset of cancer. I want you to understand, while that's a better test than nothing, that's basically saying we're going to set your safe exposure levels by counting dead bodies. That's how we do it. And that's not happy if you're one of the dead bodies. But that's how we do it. Now that's better than they have in Yugoslavia or in Moscow. I've been both places and done toxicology studies there. They have no OSHA, no EPA, but nevertheless, this is a problem. And so I want to sort of not scare you, but I want to sort of take off the frills and let you know how it really is. Let's talk about how we set a safe level for a chemical. Essentially how that's done, what you're allowed to drink in your drinking water, shower in your shower water, eat in your food, is set this, or be exposed at your job or home, is set this way. You take a rat, and you douse that rat or population of rats with a chemical, and you keep dousing it with dosages until the rat develops cancer. Okay? And then you extrapolate that rat data into human data. Now, humans aren't rats, not most of us. And I know a few. But seriously, the extrapolation from animal data to human data does not always hold. Okay? Thalidomide is a good example of that. Thalidomide was perfectly safe in rats, and it caused all sorts of devastating birth defects in women who are pregnant, okay, and their offspring. So it doesn't always make the leap from animal. It's better than no testing, but it doesn't always make the leap, number one. Number two, the dosage is singularly studied. Oh, well, let me go back to that. So how they mathematically, they douse these rats with the chemical, they see how many cancers, and this is how they come to it. They go, okay, at what dosage will we see, this is all mathematically extrapolated, at what dosage will we see an additional death from cancer in 100,000 people? Okay, and that's how they set the dosage. We're willing, in other words, to give up one person to cancer in 100,000 by a chemical exposure. That's how we set the standard. Now, in certain states, they'll say, well, we want that for drinking water to be 10 times that, or an order of magnitude higher, so 1 in a million. Extrapolate up further. So there are some additional safeguards that go on depending upon what state you're in and whether you're talking about air, water, or what have you. Now, so it's 1 in 100,000 deaths from cancer. Let me tell you some of the fallacies to this. Firstly, we're not rats. Secondly, who gets exposed to one chemical? No one. It's done in a vacuum. That rat is exposed to a singular chemical. That's not what's happening in the real world. You're being exposed to multiple chemicals all the time. So it's not done really scientifically. Because if you did, you'd have to look at the synergistic effect, the combined effect of the other chemical exposures, not just a singular effect. Thirdly, there is usually harm you can measure in a human being from these chemicals way before you ever see cancer. Cancer is, like I said, how you count dead bodies. But there is harm that you can measure today way before you ever see cancer. So those are the fallacies. With all those fallacies, we have more protection than most other countries. Okay? But I want you to understand the fallacies. You go, well, yeah, I heard the news that our water had trichloroethylene in our well water, but it was below the federal standard. I don't know if that federal standard makes you safe or not. In fact, as you can tell, I'm suspect about it because of the synergistic effect. Let me go through some examples of chemicals in daily life, and so you see how this touches each of us. Let's take DDT. I think that's a good example since I mentioned it, because there's another aspect to all this which is particularly concerning to a lot of health professionals. Let's take my pen. Let's take DDT. Let me give you the history of this chemical, and I think it'll paint another important concept to you. DDT was invented in 1929 by Dow Chemical. It was invented as a pesticide. It was invented to do something, that was perceived as a problem to farmers. Now, I say perceived as a problem to farmers because I believe farmers basically bought a lot of chemical company propaganda. And let me just get a little lick in here for environmental causes, okay? Before the advent of chemical pesticides and fertilizers and so forth, in this country, we lost about 50% of our crops to natural causes, weather, drought, bugs, whatever. Okay, with all the chemicals, the 2.6 billion pounds of pesticides that we apply to U.S. crops alone a year in this country, with all that, of which less than 0.5% of that 2.6 billion pounds ever touches a bug. Okay? With all that added, with all that expense, which would cost you more money at the food market eventually and so forth, because those chemicals deplete our soils, rob our soils of nutrients and everything else, despite all that, we still lose 50% of our crops. We haven't gained 1 ounce in crop yield. Crop yields have not gone up from 1890 to 1992. So who makes out? You get dirtier food, pesticide food, costs you more, depletes the farmer's topsoil faster, and it's got chemicals that can harm you on it. So you take a look at who makes out on that? I mean, I'm not trying to do an indictment here, but who makes out? Only the chemical company makes out. You are a marketing, recycling machine. You eat, you eat, you eat. You buy more food, you eat. You are the consumer. Okay? So let's go to that. There was this perceived need that if you're going to spray a pesticide on your crops, you want one that lasts. You don't want to spray a pesticide that the rain will wash away, that the heat will biodegrade in the sunlight, that the cold will disempower. You want something that really is resistant to breakdown. And DDT was that. It was an aromatic design chemical with chlorine on it, okay, that takes 2,800 degrees Fahrenheit to break down. You don't break the molecule down. It takes 2,800 degrees F to break it down. So it's very persistent. All right, now, it's derived from what? Oil. So it's oil-based. So you brought your apple home in 1972 from Safeway or A&P. You rinsed it off with water. The water doesn't, ask anybody to clean up with oil in your house, right? Doesn't wash it off. You bite into that apple. Your tummy does not get to 2,800 degrees Fahrenheit. It can't. You cannot break this chemical down. It goes the only oil-based system you have in your body, your fat. That's why EPA in 1987 samples U.S. people's fat tissue and finds DDT in everybody, and it was banned from use in this country in 1972. So it's been out of legal use in this country for 20 years, yet it's in all of your bodies today. The reason it was taken off the market in 1972, it was found to be carcinogenic. And so it was taken off the market. So here you have a chemical, and the mechanism I just described to you is what's called toxic bioaccumulation. And that's a very important term. Toxic bioaccumulation. What that simply means is a chemical like DDT is going in your body, and it's accumulating in your body faster than your body has any natural mechanisms to expel it. So it accumulates. If you take a fish and put it into a lake, and you add DDT to the lake, the fish's tissue concentration within about a month's period of time of DDT will be about 1,000 times higher than the lake's water concentration of DDT. We actually concentrate this stuff into fat. It concentrates in human fat or animal fat. Now, how does that affect the food chain? Well, the DDT sprayed on the crops washes with rainwater into a creek, out into the ocean, into the clams, into the fish, into the trout, up the food chain, into the on the grains, into the cows, into the pigs, up the food chain to us. We're the end of the food chain. Normally, we're not eaten by anybody. Okay, and so therefore, that's where it ends. And that's why you have these 60-some chemicals And that's just what we've studied that you can find in human beings' tissue. And it looks to be dose risk related. The higher that internal dose builds up over time, the more increased risk you have. If it was just DDT that we painted the story with, then we wouldn't have the trouble or the concern that we do in medicine today, because this has repeated itself with other chemicals like PCBs, chemical used in electrical transformers for years. It was used to increase the conductivity of electricity in a transformer, and when the transformer got very hot, it would not break down, the heat would not break down the viscosity of the oil in the transformer. It would extend the life of the transformer. Just like your car engine, if it gets too hot, the oil doesn't lubricate anymore, it seizes. Well, if you have a $500,000 electrical transformer out behind, Columbus Power and Light, you want it to last. So they added PCBs to electrical transformers, to capacitors in television sets, out on every third telephone pole. It was a miraculous chemical. It went into all these devices until '72, when we found out Monsanto hadn't done its homework, and in fact it was carcinogenic and suppressive of the immune system, and it was banned. But we couldn't shut down the country. All those electrical devices were still in service. They would leak into a sewer drain, out into the ocean, dumped in a toxic landfill, into groundwater. It would, again, start to build up the environment, because it takes 3,200 degrees Fahrenheit to break down. It's not going anywhere. So we're the end of the food chain on that. And this repeats itself with 60, 70 some compounds, and probably more than we know. Certain drugs store in the body's fat tissue. That's been reported in the literature. Diazepam, Valium, has a very oil-soluble nature to it. It can store in the tissue. You can find it in people's tissue months after they stopped any dosage of that diazepam. Marijuana, the active ingredient marijuana, tetrahydrocannabinoid, highly oil-soluble. By the way, highly neurotoxic and highly carcinogenic, which they didn't know 20 years ago, but that's been published, readily stores in the fat tissue. Certain forms of cocaine will store in the fat tissue. A chemical, if it's got an oil base that doesn't easily break down in normal digestive process, is going to store to some degree in the fat tissue. And so that's an example. Another example, dioxins. Dioxins are a chemical, let me go back a second, because this is particularly relevant here in the Midwest. When you make herbicides, things to kill weeds or green things, okay? Herbicides. It sounds like an oxymoron to me, but anyway. When you devise herbicides, in the normal production of them, in that process, chlorine comes in contact with organic matter, and what can be formed as a trace element in those herbicides is a chemical known as dioxin. Now, one report shows that, to give you an idea how toxic dioxin is, 4 ounces of pure dioxin, by one report, would kill 8 million people in New York City if it was added to the New York City water supply. So this is one of the most toxic chemical man's ever contrived. So very small amounts can potentially have real lasting effects. This chemical came into real concern during Vietnam, because the herbicide used to kill the jungle vegetation in Nam was a thing called Agent Orange, herbicide orange. And what they did was they sprayed this on the jungles so the jungles would die real quickly, and they could shoot the Viet Cong. They could see them. And in the process of doing that, we sprayed our own troops. The guys who did it didn't wear any gloves, masks, or protections, and we spread the stuff all over the place. And Dow kept making it, Monsanto kept making it, and we kept spreading it. We didn't win the war with it. And many veterans came home with complaints, and they felt that they were connected to this, working with this Agent Orange stuff. However, because dioxin can cause a harm at such a low concentration, at the end of the Vietnam War, when these veterans had these complaints, there was no analytical laboratory test where you could measure it in the body at those concentrations. At that time, we could measure maybe 1 part in a million in laboratory analysis. Now we can measure parts per quadrillion. So like, to give you a concept, a visual concept of that, a drop of water in a large swimming pool is about a part per million. A drop of water in a fair-sized lake is a part per billion. You see, so when you get to a part per trillion or a part per quadrillion, you get an idea of how fine analytical technology has come. But because they probably had levels at parts per trillion that were causing them a problem, you wouldn't get it at parts per million because it was at lower levels than that. So when they came home and were tested, the doc said, well, there's no dioxin in you. Must not be a problem. Must be psychosomatic. You must have smoked too much marijuana in Nam. And that was the basis of the complaint between the veterans and the VA for so many years, until Arnold Schechner and a few doctors got the analytical devices down and said, wait a minute, we did a study on Agent Orange vets, and sure enough, they have higher levels of dioxins than people that weren't in Vietnam. And North Vietnamese have higher levels than South Vietnamese, and so forth and so on. And so it does seem to be there clearly was a link, but it took 20 years and all sorts of aggravation for the veterans to find it out. Now, when you chlorinate an organic material, you can produce trace amounts of dioxin. Here's one that's really concerning. When you bleach paper pulp, you get dioxins, trace amounts. That's why the US EPA now advises anybody living downriver from a paper mill, do not eat the fish caught in the river downstream from a paper mill. That's like a blanket order in the United States today. Why? Because those fish are loaded with dioxin. What about the paper? Milk cartons, egg cartons, disposable diapers, toilet paper, paper towels that have been bleached in this process have trace amounts of dioxin. So when you go to the supermarket and you see that unbleached coffee filter, good idea. Okay? That's why they're making that. Okay? They are trying to do whitening processes and bleaching processes with paper that don't use that kind of chlorine bleach that causes the dioxin formation. But you're probably better off with unbleached paper products. Okay? Something to consider. So these are chemicals that are ubiquitous, all present in your environment, and can build up in your body. And they repeat themselves very often. Now, I can go on by chemicals, but I could spend the rest of this evening on that. Let me go into what I call the myth of safety. And this is hard to confront. It's not easy to hear, but you need to hear it. So far be it from me not to say it. I want to sort of erase the myth of safety that I grew up with in my life, and you probably have equally grown up with, maybe to a lesser degree because environmental issues have come more to the fore. But I want to sort of erase some of the myths of safety that we tend to live under. Firstly, let me give you an example of how this works. Let's take dioxin. When the Vietnam veterans came back and said, we've got a problem with dioxin, Monsanto said, well, we'll study it. Now you have to remember something. In this country, our government doesn't spend that much money on testing chemicals. Normally they'll take the industry data that uses or generates those chemicals and they'll review it. Maybe do a side study off of it or what have you, but essentially the basis for a chemical hazard evaluation of any particular chemical is provided by the industry who produces it. So it's a little bit like paying the fox to be a security guard at the chicken coop. But that's how it works. Better than no system, but that's how it works. That's one myth. You have to understand who is doing the studies. It's not that great and wonderful federal government. Okay, number one. Number two, they lie. Okay? They lie a lot. And let me give you specifics of the lies that have been documented. Okay? Dioxin said, look, we're concerned about these Agent Orange veterans. We understand there might be billions and billions of dollars of lawsuits. Let us do this. We'll take workers that make the stuff in our plant, and we'll study them for increased cancers, birth defects, what have you. Surely they have more exposure than the non-vets. And they did. And that study showed that there was no significant increase of any kinds of cancers in Monsanto workers who made Agent Orange than in Monsanto workers who didn't. It was that study that became the cornerstone of the U.S. government's position and our safety standards position in paper towels, in fish, and anything else of what level was safe, of what exposure to dioxin was safe. It was the cornerstone of how we set those limits. In 1986, 1987, the ex-Monsanto medical director was under oath in cross-examination in a lawsuit. And under oath in cross-examination, this was reported in the Journal of Pesticide Reform, he admitted that they fudged the study. That there were 16 cancer deaths that for bogus reasons they threw out of the study so the numbers would come equal to normal. So in fact, the very basis by which we were set limits to your and mine and other people's exposure was totally fallacious, and in fact was at a level that was causing a dramatic increase in cancers. So that's, to give you an example, one example, where one of the most toxic chemicals to man The basis of human safety standards was based on a lie produced by the chemical company Monsanto that produced it. Okay, but this story repeats itself. Malathion. Now, you're not from California. I don't know if they spray malathion here in Ohio. They probably do, but maybe not from helicopters like they do in Los Angeles. I was always curious when they were doing this a few years back. You know, I mean, I've never seen a med fly on Hollywood Boulevard, you know, that got in a truck and hiked over to the San Joaquin Valley. You know, I don't know how they ever got over there, right? But for some reason, they felt that the urban population needed to be sprayed by malathion. And there weren't many, you know, orange trees growing in Hollywood, right? But that's where they sprayed. It was like unbelievable. And but seriously, let's go how that study was done. In 1986, when the first medfly outbreak happened up in the Santa Cruz area in California, Governor Brown was under a lot of heat, as you can imagine, from agriculture. He went to his health department. He said, "Give me a study. Tell me what is this, if we can if it's safe to aerial spray malathion." He gave that charge to the then head of the hazardous evaluation section in the Department of Health, Dr. Ephraim Khan. Okay, Ephraim Khan looked at that data. He gave it to the past head of his department, a guy who worked for him now, Dr. LePay, and he said, "LePay, give me the hazard evaluation on this." So how that's done is they took what was a reasonable idea. Is they took a baby pin, 10 by 20 square piece of grass, and they extrapolated mathematically how much increased risk of cancer that baby would have in that crawl space of 10, like a playpen size, if they did 6 aerial spraying, which was the average number needed. Would there be an increased cancer or any kind of health consequence? And what LePay found and reported in writing to Khan was, "I can't tell you it's safe. I can't tell you it's definitely unsafe, but it's definitely, the data is equivocal. It's not clearly safe. And I recommend we do not aerial spray because it isn't clearly safe. There is some real concern here." What Ephraim Khan did, because he was under a lot of political and industrial pressure, he said, "Well, look, if we reduce the crawl space to 2 by 3, the size of an open newspaper, okay, then the numbers come down and the risk assessment is less, and we can justify it." So with a stroke of his pen, he changed the crawl space to 2 by 3, and the numbers of risk came down, and it was on that basis, on a hand/memo, that they justified spraying malathion on 20 million people in Southern California for 2 years. Okay? Now they've come out with a scientific study that shows, in fact, all those people complaining, absolutely it does cause neuro damage for certain people at certain levels of exposure. I don't think you'll ever see it sprayed again. Okay? Now, how do I know that? Because a group I work with got under Freedom of Information, the Freedom of Information Law, we got all the internal California state documents on the malathion approval process, and we have Khan's note. It showed how he did this, and we gave it to the LA Times. He took a little heat. But that's how we found out. So it wasn't something that was safe to do. And I'm giving you these examples because it takes off the fallacy of safety. You know, I don't know how many of you drink diet, NutraSweet, anything. But again, Dr. Remington from the American Academy of Environmental Medicine did a paper on this in Tahoe a few years ago, where he did a Freedom of Information retrieval on the FDA's NutraSweet approval process, okay, on aspartame. Now, this is important since many of you might have yourself or children eating this stuff to understand how that was approved. What he reported was that 22 of the FDA employees or consultants who were under FDA's hire, who were part of the team that approved NutraSweet as safe for use, human consumption, 22 of them, within 1 year after NutraSweet's approval, were working for SD Searle. 22 of them. That's not 1 or 2. 22 of them. SD Searle, on the approval of NutraSweet, in 1 year went from a $60 to a $600 million a year company. There were 2 creditable laboratory animal studies that showed increased lesions on the brain in rats from NutraSweet, and they were buried and not considered, and yet they were fine studies. The chemical is definitely neurotoxic, probably causes brain lesions, particularly susceptible to young children who are getting far more dosages than their body size to an adult, and should not be consumed for any reason. it's really a toxic substance. And yet, it was approved. You know who owns Testisro? Monsanto. So, let me tell you another little story, and then I'll get off of the myth of safety. I think I've shook you up enough. We'll talk about some things you can do. Okay, it's not all doom and gloom. But another project I worked on is, you know, in this country we have a wonderful practice that if we make a chemical that's too toxic here and it's banned, we can export it legally. So when a chemical gets banned in this country, we ship it to Sri Lanka, India, Ceylon, Guatemala. I mean, great PR. We wonder why our goodwill isn't good with some of these third world countries. We're just poisoning them. So we did a study where we actually went into and it's all very clandestine. In other words, there's so many laws that protect a company having to register their name and a specific chemical going where. It's all under the guise of free trade and competition, right? So a chemical company does not even have to register what it's shipping where by its own name. But if you go through painstakingly export documents with the Customs Department, which even the GAO hadn't done, and you go through and you figure back the codes in a fairly complex way, you can actually find out who shipped what to who. You have to sort of figure it out. It's like a maze with a code. And we did this. We spent a lot of money to do this. And we found, for instance, the day that chlordane, a termicide used in this country to kill termites in almost all of our homes for years, 30 years, which bioaccumulates in our tissue, most of us have there. It was banned in '84. In the 3 months following its ban in this country, Vasicol Chemical, who made the majority of it, increased its exports of it to third world countries 400%. 400%. We are exporting about 2.5 tons an hour of pesticides banned in this country to third world countries for profit. It's morally unconscionable. We just cannot believe that we would do that, and yet our government permits it. The sad story though is the circle repeats itself and comes back to us, because where do we get our vegetables and fruits in the winter? From third world countries. So that is the circle of poisoning. So this is another source of exposure. Okay, so let me talk about sources of exposure and then things you can do. Okay? Okay, so I gave you some examples of chemicals and how they can bioconcentrate in the tissue. Let me give you some other examples. Food. There's 3,000 additives approved for use on our food. There's 55 pesticides used on food that cause cancer that are legally used in our food today. The wax of fruits, the wax that's used to do fruits and vegetables to make them shiny, the apple nice and shiny in the supermarket, okay, that usually contains 1 of 2 fungicides which are immunosuppressants. They don't even have to register these fungicides because it's applied after growth. It's not applied during growth. The wax they normally use on those apples, oranges, peaches actually uses it, cucumbers, is usually shellac. Fine for your car, I don't know if you want to eat it. There is a federal law that states that if fruits or vegetables have been shellacked, you must have at the point of sale a sign clearly displaying that they have been waxed. That's a federal law, okay? And if violated, the grocer is fined and possibly imprisoned. It carries criminal prison penalties, right? Totally unenforced in this country. Anybody see one of those signs? So I remember Kirstie Alley, who got really up in a tirade on this once when she found that this wasn't done. She called the EPA. They said, "Oh no, the FDA does it." She called the FDA. The FDA said, "No, we don't do the California State Board of Health's responsible." Called the State Department of Health in California. They said, "No, it's the County Board of Health." Called the County Board of Health. County Board of Health said, "We only have a person who works, 12 hours a week on food, and they're not here." So that's, I'm sure it's not much different in Ohio. It's probably worse in Ohio. So food, chemicals that are applied, injected, etc. to food. Water. Most concerned water is lead from the pipes in drinking, but you can have solvents and so forth. If you're on well water, it might be a good idea to test it and so forth. Well water. Air pollution. Benzene, toluene, lead, ozone, those kind of chemicals are in air. Particulate, dust, so forth. Chemicals in your home. I mean, most homes have an average of about 10 to 12,000 different chemical compounds in a home. A home can be the most toxic place you're ever in a day. Okay, particularly if the ventilation is incorrectly, or you have radon levels in your basement, which are common here in the Midwest, more so than the West Coast. If you're using formaldehyde-containing carpets or wall coverings or glues with isocyanates or benzenes or toluenes or toxic paints, and on and on and on, building supplies, hobbies. I think artists get more toxic than any group of people I know because they work with their art chemicals and they wear no masks, no gloves, and yet a person in industry working the same chemicals has a respirator on and rubber gloves. You know, so artists typically, even home hobbyists, get exposed unwittingly. Household pesticides, these are some examples of your exposures. What can you do? First of all, find a doctor who understands this. The National Institute of Medicine stated in a report a year and a half ago that the normal, good family doctor is wholly untrained to diagnose a chemical problem. Example of what I'm talking about. Child comes in, the child's hyperactive. Kids like bouncing off the walls. Mother's bouncing off the walls because the kid's bouncing off the walls. Teacher is going to throw this kid out of school. Okay? Goes into the doctor's office. Doctor says, you need some Ritalin. We're going to quiet you right down. The problem is that Ritalin, when the kid gets to be about 12, goes through puberty, actually acts like a speed on the kid. And he actually speeds him up, so they have to switch from Ritalin over to some kind of sedative. So the kid's usually on drugs for life once you start him on Ritalin. Where in fact, if you looked over the kid, Feingold talked about this, my gosh, Doris Rath's written a book on it. You look over the kid and you find out, God, he's eating sugar like crazy. Every time he eats sugar, he goes nuts. He's eating all these preservatives on food. They're all synthetic. It's probably making him weird. Do a blood test and find he's 4 times the average normal of lead. One of the symptoms of lead, low-level lead exposure, is hyperactivity. And you take those things out of his environment and food chain, all the kid's normal. Calms right down. Doesn't need a drug. Don't have to give him another toxin. That's how misdiagnosis causes a problem. Oh, because most physicians are not trained adequately in environmental and toxicology to perform a diagnosis of when there is a chemical problem. There are tests that can be done, that physicians can do today, that more and more show. One, we can do blood tests that can scan 50, 60, 80 of the most common compounds in your blood and see if your level is comparatively high or low to the general population. We can actually test the tissue with a fat biopsy to the buttocks or the gut with a needle. You don't have to do it with a knife. We can get a half a gram of fat and you can analyze some of these chemicals, see if they're higher than normal. There are antibody tests that can be done in blood, which a doctor can do, and show indications because of the number of antibodies to chemicals that you've built up if you've had a higher exposure to things. One of the areas you can test is the central nervous system. The first sentinel of harm is the central nervous system. The first system in the body we usually see harm is the central nervous system, the next is the immune system, and then it's cancer. Okay, so cancer, like I said at the beginning, is at the end of the line. But you can measure deficits in reaction time, in IQ, in short-term memory, in visual perception, in long-term memory. All those things can be measured, and if they are being contributed by a chemical buildup or exposure, you can isolate that and then eliminate it. Okay, so there are tests that can measure neural function before your brain damage, okay? But where it's nevertheless causing harm. There are tests that can measure immune system function now, antibody tests, lymphocytes, which are white blood tests, and show the health and the structure of the immune system. These tests can now be done, so if there is something compromised with the immune system, there are tests I know that Dr. Carey does in physicians like him that can show if you have a reaction to a particular chemical or a food, and then maybe they can come up with some way to neutralize that, or you can avoid that chemical in your food or in your daily life. So there are things you can do now with a physician who's been educated or somewhat educated in this area to avoid. Because the first thing you want to do is avoid. It's the cheapest thing you can do, is avoid exposure when you can. If you can buy organic fruits and vegetables, why not? Okay? If you can put a water filter on your faucet, why not? In LA, one of the worst exposures people have in a day is taking a shower. Because in LA, we commonly have chlorine chemical compounds in our water. Chlorine compounds and solvents will absorb through your lungs far better than they will absorb through your skin or if you drink them. So the steam from a hot shower, if that water has not been filtered, will typically be the highest rate of absorption of chlorine compounds in your water. If you have concerns about your water, have it tested. If it does have solvents in it or lead in it, filter it. There are things you can do that do not break the bank. Your shower you can filter, your drinking water you can filter. That do not break the bank, that can markedly reduce your exposure. You're never going to avoided totally. But so if you eat sensibly, good. If you drink sensibly, good. If you avoid things that have chemicals in them, good. These are all major reductions. If you do not take drugs unless you absolutely need them, good. If one doctor tells you to take a drug, you're not sure, get a second opinion. Good. Reduce the chemical intake. That's one thing you can do. And there are tests now that can measure immune system, central nervous system, and actual toxic levels of many of these substances to tell you if there might be a problem or if some problem you have might be connected to their buildup in the body. If that occurs, there are some things you can do. How do you get these chemicals out of the body? The ones I described to you, time doesn't do that. Okay, you might say, well, gosh, that's a good way, that's a good reason for me to go on a diet. I need to lose a few pounds, lose some of that fat, lose some of those chemicals. Okay, unfortunately, the body will metabolize fat. Ask anybody who's lost weight. You can metabolize fat. But they won't metabolize the chemicals that are in the fat, so when you lose weight, you'll concentrate the chemicals in what fat is left. You actually get a little bit per pound more toxic. Because the chemicals don't break down, the fat does. So dieting isn't a good solution. It might be a good solution for your appearance and your heart, but it's not a good solution for getting chemicals out of your body. If you have a heavy metal exposure, or documented lead levels or some heavy metals in your blood, one of the treatments you can do, which is standard accepted practice, is what's called EDTA chelation. EDTA chelation. And let me explain that. Chelation is from the Greek word meaning to claw. Chele. Okay, and what it is, it's a chemical that's given IV to the vein, and it claws to the heavy metals that are dissolved in the blood, and it will pass them out to the urine. Okay, so it gets heavy metals out of the blood. This was first really came into being at Kerr McGee when Karen Silkwood and her compatriots were exposed to plutonium. And these people were going to die of leukemia, and it was just a matter of months or whatever if they didn't get this heavy metal, plutonium, out of their body. Now this is a heavy metal, like lead, like certain forms of lead, mercury. It's in the blood. It's not in the tissue yet. So EDTA chelation will go into the blood, grab that heavy metal, and pass it out to the kidney and the urine. It's effective for heavy metal poisoning, immediate heavy metal poisoning. That's one solution. There's a chemical called cholestyramine, this drug, which was found to combine similarly with ketone, which was a pesticide additive down in Virginia. And so it was. So if you had a ketone exposure, if you lived along the St. James River in the 70s near Allied Chemical, cholestyramine would help get that chemical out of your body. But we tried it on a lot of different other chemicals. It doesn't combine. So it just had the propensity with one other chemical. So first, avoidance, EDTA chelation for heavy metal exposure, cholestyramine treatment if you've had that type of exposure. And I'll tell you the one that we've found most successful in the studies that we've done for detoxification was a sweat-out program that was devised in the late 1970s as an adjunct to drug rehab. In the late 1970s, Hubbard, the guy who wrote Dianetics, came up, he did a lot of work in drug rehab apparently, and he came up with a sweat-out program because his concept, as I read it, was drug storing the system. So one of the reasons that people have such a high reversion rate, 80% of people that go through a drug rehab program revert within the first year. And it costs $15,000 to $20,000 to go through an inpatient drug rehab program. So it costs all of us in our medical bills. That high reversion rate might be worth it just for the 20% that don't, but it's not very effective technology. Anyway, his concept apparently was that the drugs stored in the body. So even though the person was off the drugs of addiction and through withdrawal, he still had them in their tissue, and it might cause cravings or flashbacks or what have you. So anyway, he wrote a sweat-out program, but he made no medical claims, took no copyrights on it, and put it in the public domain. Myself at the Research Foundation heard about this program, and we were attracted to it because it used something that seemed very simple and yet very unique. And that was the skin. It was a sweat-out program. It used the skin to excrete. And that caught our attention because there was a lot of medical literature that showed how things like methadone, amphetamines, lead, PCBs, PBBs come out to the skin. And so we felt if you could dramatically increase the skin excretion, that might be a way to lower the body burden. We felt it was academic that lowering the body burden had to be done. If these chemicals that build up inside of you, it can only reduce your immune system, the central nervous system. If you could eliminate them safely, then you would see probably those systems come back or improve. That was the hypothesis. So we decided to study this Hubbard program, and a group of scientists got together. We devised a protocol, and we tested it first on Michigan residents who were poisoned with PBB in 1971 in Michigan and Ohio. We brought them. They had been studied by Mount Sinai of New York by Irving Selikoff, the leading toxicologist in the country, and they had been monitored for about 10 years. And their levels of PBB, it's a chemical similar to, it was a flame retardant chemical similar to PCBs, that had been inadvertently crossed at Vesical's factory. See, Vesical made two chemicals. Nutrimaster, which went into cattle feed, which was magnesium oxide, just bulked up cattle. And they made a flame retardant chemical that went in fire extinguishers and stuff. Well, they crossed the two. So out into all the cows, chicken, eggs, milk, butter, cheese, people went PBB, which is carcinogenic immune suppressant. And pockets of farmers and cows and chickens started dying and getting ill. And so Selikoff was called in from Mount Sinai because the Department of Health in Michigan, who was on the hook since they distributed the stuff through co-ops, didn't want to look at the problem. So Selikoff was called independently, studied and published in the Journal of the American Medical Association a number of studies on this incident, considered the largest agricultural contamination in the history of the world. And 10 years after studying with actual tissue biopsies, found the levels of PBB in Michigan residents hadn't gone down 1%. The stuff stayed in the body. So we felt, since he had those patients already biopsied and studied for 10 years, we took some of them and put them through the detox and redid their biopsies, we could find whether this Hubbard program could reduce these chemicals at all, and if it did so, was it safe? Did it have any side effects? So we did our first study on Michigan residents. We found in a 3-week detoxification treatment, we reduced their chemical levels of DDT, PCBs, PBB, because they had all those, we tested them all, 68%. More importantly, all their symptoms vanished. The skin acne, the liver enzymes that were abnormal, the liver function was abnormal, their neural function improved, their IQ went up 8 or 9 points, and we published this in the Royal Swedish Academy Journal, which is a society, AMBO, which is a Society of Awards Nobel Prize, which is a prestigious international journal. So we saw in our first 2 studies with this Hubbard program, it was safe, it was effective. Let me describe it in brief, and then I'll take some questions on all I've covered. I know it's quite a bit. How the detoxification program works is you have to move the chemicals from the fat into the bloodstream first if you're going to get them out. If you move chemicals into your bloodstream from your fat too quickly, you'll get sick. You get you're feeling like poison, because you would be, okay? If you moved them too slowly, like you do every day, nothing happens except it maybe slowly erodes at your immune system or contributes to allergy-type symptoms or hypersensitivities. But because what happens is your fat doesn't just stay there. We move fat into our blood every day. That's what triglycerides and cholesterol are. You move more fat into your blood when you exercise, or if you fast, or actually if you sleep at night because you're not eating. And so these are mechanisms that will increase the fat levels into the blood. Well, on the Hubbard detox, what you're going to do is induce mobilization but control it. So you don't over-mobilize it or under-mobilize it. And that's done with a controlled dosage of niacin. Vitamin B3 mobilizes fat into the blood. Okay, so a controlled dosage of niacin, starting off with a low dosage, 100 milligrams or so, increasing up to higher and higher dosages over the course of about a 3-week, 4-week treatment. Because you can't increase them too quickly. If you do, the person will over-mobilize. So you incrementally increase dosages over a 3 to 4 week period. You follow the dosage of niacin taken orally with a physical therapy routine to increase blood flow and circulation. If that's sort of dormant, it's hard to get blood flow in it, you've got to push the person through some physical therapy exercise to increase circulation. Then low temperature heat, sweat it out of them. So now you've mobilized, how do you get out? It's not going to easily break down to the gut, that's why it's in your body. So the one way you can get it out without having to go through metabolism is through the skin. It bypasses digestion. Simple, brilliant, works. Now, the thing that most people don't realize is that every place you have a hair follicle on your body, you have a sebaceous gland, which is an oil gland, this stuff, skin oil. That's different than sweat, which is water-based. Heat increases both the rate and the volume of sweat and oil excretion through the skin. So you're exacerbating 2 excretory routes, sweat and sebum or oil, both. The heat you use is like in a dry sauna, akin to a dry sauna. I mean, not like a health club sauna because they're too hot and they don't ventilate them. These are like about 50 degrees lower in temperature than a health club sauna, highly ventilated, cross-flow ventilation. The person goes in after the exercise of niacin, 10 or 15 minutes, comes out, cools down, takes a shower, goes back in, 10 or 15 minutes, comes out, cools down, so forth, goes back in, comes out. And when you do this, you might excrete through your skin in water and oil in one day 4 to 6 pounds of excretion, marked excretion. Now when you excrete that kind of fluid and oil, You're also excreting calcium, sodium, magnesium, vitamins, minerals. Those are all replaced. If you don't replace them, the person's at risk of deficiency. So those are all replaced. And that's part of the protocol. You also have to replace the oil. You're losing toxic fat. You better replace it with clean fat. It also helps increase the amount of bile you're producing. So some of this will pass through the bowel. Okay, this is all monitored by a physician. It should be, particularly if someone is ill, because it has to be monitored, blood tests and so forth. Highly effective. Now, when we did the studies, we sampled the sweat. We found DDT, PCBs, dieldrin, chlordane, THC from marijuana smokers. It was right there coming out. This has all been published in about 8 international medical journals now. Different studies we've done. It does come out. The tissue levels confirm it. The program is safe. Average improvement in adult IQ is 9 points, published. Average increase in reaction time, physical response time, 18 points. Average improvement in blood pressure, 20%. Reduction of cholesterol, 30 points. These are average published results. So it has an incredible beneficial effect. People who have chemical sensitivities tend to react to lower levels of chemicals more, which is more and more common in this chemical society. What it seems to do for them, and I don't believe in cure-alls, but what it does for them is if you can reduce the internal chemical load internally, what they're being exposed to all the time, the endogenous or internal chemical load, their reaction to external stimulus seems to be less, and when they do have a reaction, it's less in duration or intensity. So the degree of improvement on a chemically hypersensitive patient differs by patient because you have to understand, well, what's causing that patient's chemical sensitivity or hypersensitivity. It can be a combination of things, of which internal chemicals is just one. So it's not a one-brush cure, it's an invaluable tool. Theron Randolph, the founder of environmental medicine, was who actually posited using this detox program for that particular type of patient initially, and it was he and, in fact, Eileen Buckholz, who came to us years ago and said, we'd like to try some of these chemically sensitive patients with this treatment, and it was found to be very effective for them. Again, not a cure-all. They still have to avoid chemicals, etc. They still have to do certain things in life, but greatly improved for almost every case the quality of their life. With that, I'm going to recommend some reading, and then I'll take questions. One book to read on the detox program. You can get it in any bookstore. You know, Walton Dalton's Clear Body, Clear Mind. Hubbard wrote a book on it. It came out about a year ago. You can buy it at any bookstore. It's called Clear Body, Clear Mind. I think one of the best books to read in terms of what you can do in your home to clean it up is a book by Deborah Lynn Dadd, D-A-D-D, called Non-Toxic Home. It gives you a lot of non-chemical alternatives to chemicals in your home. Great thing to read. I think one of the best books to read in terms of what foods are safe, Diet for a Poisoned Planet by David Steinman. And that's in any major book. I think it just came out in paperback. And he actually tells you what in the United States, what fish, what meats, what vegetables, what fruits have what levels of what chemicals. So when you go to the supermarket, he gives you a really easy code: red, green, and yellow. And so you can really, like, say you can buy foods based upon least toxicity. For example, the most toxic food he found were raisins, which makes sense, right? We know from Cesar Chavez how many 16 different pesticides they spray on grapes. Okay, take the grape, you dry it down, make it concentrated. What do you got? You got a pretty toxic raisin. So things like that, really helpful. He evaluated very carefully the fish in the Great Lakes. So somebody living in this area of the country, it's invaluable data to have. What fish in your streams and lakes are safe, what aren't. Great book. Alternative Approach to Allergies, the new edition by Theron Randolph. He has a section on detoxification, which I worked with him on. It talks about this treatment and environmental allergies. It's a good book. There's 2 books I want to plug from the environmental end. One is a book that I helped work on by Don Henley and David Marsh called Heaven is Under Our Feet. And it's an anthology from authors like Congressman Kennedy, Gandhi, Paul Saugus, Senator Kerry, Jack Nicholson, Tom Cruise, various different people in arts, government, on the environment. And all the proceeds from the sale of that book, and it has a lot of helpful things in it on environment and things you can do for your own environment. And all the proceeds of that book go into buying up the land that's in danger of development around Walden Pond. And I was just at Walden this Sunday. We did a march at Walden to raise money, and I can tell you from there, it'd be like, it's tantamount to me to painting graffiti on the Statue of Liberty. You know, we just can't allow that environmental icon to be destroyed by Mort Zuckerman, who wants to build condos on it. You know, so. But the book is a great book, and I advise reading Environmentalist. Another one is 50 Simple Things You Can Do to Save the Earth, which is a bestseller. It's a little paperback. Great things you can do. That is chock filled with data. For instance, do you know that if we all ate 10% less meat in this country, with the grain we would save, we could feed the 60 million people that will die of starvation on this planet next year? Did you get that? We ate 10% less red meat in this country, all of us. The grain we would save from feeding cattle would feed all 60 million people that will starve to death on this planet next year. You see, not only that, what's one of the most toxic foods? Beef. Why? Fattiest. Least toxic food? Vegetables and fruits. Why? Least fatty. Okay? So, from just an environmental and health perspective, good to eat lower in the food chain. So, little facts like that are available to you. That's it. Questions?